Have you ever wondered how much of our daily lives depend on electric motors? From the refrigerators that keep our food fresh, to the cars that drive us to work, to the power tools that make our jobs easier, electric motors are virtually everywhere. They're in our homes, our offices, and our cities. They're in our phones, our computers, and our machines. But what exactly is an electric motor? In simple terms, it's an electrical machine that converts electrical energy into mechanical energy. In other words, it takes the electricity that flows from our power outlets and transforms it into motion. This transformation is not only fascinating, but also crucial for our modern civilization. Think about it. When you turn on your blender to make a smoothie, or when you start your car to head out for a drive, you're relying on an electric motor. The same goes for when you use a drill to hang a picture, or when you use a fan to cool down on a hot day. Without electric motors, these everyday tasks would be a lot more complicated. And it's not just about convenience. Electric motors play a pivotal role in many heavy-duty applications too. They're used in industrial fans, blowers, and pumps. They're used in machine tools and in huge machines that are used for ship propulsion, pipeline compression, and pumped storage applications. They even power the hard drives that store data on our computers. In essence, electric motors are the unseen heroes of our modern world. They're the silent workers that keep our lives running smoothly. They're the powerhouses that drive our industries and fuel our economies. And the best part? Electric motors don't just move things around. In certain applications like regenerative braking with traction motors, they can also be used in reverse as generators to recover energy that might otherwise be lost as heat and friction. This makes them not just efficient, but also environmentally friendly. Indeed, electric motors are integral to our modern way of life, but have you ever wondered where and how they originated? The journey of electric motors begins in the 18th century, a time of great scientific exploration and discovery. Science was a playground of endless possibilities, and two individuals in particular, Andrew Gordon and Benjamin Franklin, decided to venture into the uncharted. Their curiosity led them to create the first simple electrostatic devices in the 1740s. These devices, while rudimentary, were the precursors to the electric motors we know today. Gordon, a Scottish monk with a knack for science, and Franklin, a polymath who needs no introduction, were not alone in their quest. Across the ocean, Henry Cavendish, a British scientist, was making a discovery of his own. Cavendish, in his isolation, stumbled upon a fundamental principle that would later be known as Coulomb's law. This law describes the force between charged objects, a crucial understanding for the development of electric motors. However, Cavendish, a man of secrecy and solitude, did not publish his findings, leaving them hidden from the world. It was Charles-Augustin de Coulomb, a French physicist, who independently discovered the same law and decided to share it with the world. So despite Cavendish's initial discovery, the law is now known by Coulomb's name. These early motors, operating under the principles of Coulomb's law, were remarkable for their time, but they were far from practical. Generating the high voltages necessary for these electrostatic motors was a daunting task, rendering them more of a scientific curiosity than a practical tool. Yet, every great invention has its humble beginnings. The electric motor was no exception. These early experiments laid the groundwork for what was to come, paving the way towards a revolution in technology and industry. However, these early motors were not practical due to the high voltages they required, but a significant invention was about to change that. The invention of the electrochemical battery by Alessandro Volta in 1799 was a game-changer. With this breakthrough, the production of persistent electric currents became a reality, opening the door to the development of practical electric motors. Before this, the world had seen simple electrostatic devices, the precursors to modern electric motors. These devices, experimented with by the likes of Scottish monk Andrew Gordon and American experimenter Benjamin Franklin in the 1740s, operated on electrostatic force. However, due to the difficulty of generating the high voltages they required, these early motors remained more of a scientific curiosity than a practical tool. But with Volta's battery, the landscape changed dramatically. Persistent electric currents could now be produced, and it was only a matter of time before electric motors moved from the realm of novelty to necessity. In the early days, the electric motors were brush types, using brushes to conduct current into the rotor, the moving part of the motor. But this design had its limitations. The brushes wore out over time, leading to reduced performance and eventual failure of the motor. Then came the brushless motors, a significant leap forward in the evolution of electric motors. These motors didn't have brushes, hence no wear and tear. Instead, they used a controller to switch the current direction, eliminating the need for brushes and significantly increasing the motor's lifespan. Along the evolution journey, motors also diversified in terms of power source type, construction, application, and type of motion output. Single-phase motors operating on a single unidirectional voltage wave became common in low-power applications like household appliances. On the other hand, two-phase and three-phase motors, which work on 2 and 3 voltage waves respectively, found their place in industrial applications due to their higher power output and efficiency. The evolution story of electric motors also includes axial and radial flux motors. In axial flux motors, the magnetic field runs along the motor's axis, while in radial flux motors it runs radially or perpendicular to the axis. Each type has its own advantages and is suited to specific applications. Today we have a variety of electric motors, each designed for a specific purpose. From powering industrial fans, blowers, pumps, and machine tools to running household appliances and electric vehicles, electric motors have permeated every aspect of our lives. We even have tiny motors in our watches and large ones for ship propulsion, pipeline compression, and pumped storage applications, some with an output exceeding 100 megawatts. Over time, electric motors have not only evolved but have also found a place in almost every aspect of our lives. From early experiments with electrostatic force, we have come a long way to modern, efficient, and diverse electric motors, proving once again that necessity is indeed the mother of invention. Today, electric motors are everywhere, from the smallest watches to the largest industrial machines. Imagine a world where electric motors didn't exist. It would be a world without many of the conveniences we take for granted. Electric motors are truly the unseen workhorses of our modern society, powering everything from our kitchen appliances to our cars. In the industrial sector, electric motors drive fans, blowers, and pumps, making factories, power plants, and water treatment facilities work efficiently. These motors, which can be as large as a room, are often standardized for industrial use. Some of these mammoth machines generate power exceeding 100 megawatts, used for ship propulsion, pipeline compression, and pumped storage applications. In our homes, smaller electric motors whir away inside our washing machines, refrigerators, and even our toothbrushes. But it's not just about size. These motors may be small, but their role is significant. They help us do our chores, keep our food fresh, and maintain our oral hygiene. Our vehicles, too, are becoming increasingly electrified. Electric cars powered by electric motors are fast becoming the norm. These motors not only provide a clean, emission-free mode of transport, but also offer a smooth and quiet ride. In the digital age, electric motors have found a new home in our computers and laptops. They spin our disk drives, ensuring we can store and access vast amounts of data with ease. But electric motors aren't just about consuming energy. They also play a critical role in energy recovery. In applications such as regenerative braking with traction motors, electric motors work in reverse as generators. They recover energy that might otherwise be lost as heat and friction, feeding it back into the system. This not only makes our machines more efficient, but also helps conserve energy. The journey of electric motors from simple electrostatic devices to today's sophisticated machines is truly a testament to human ingenuity. From the smallest motor in a wristwatch to the largest motor propelling a ship, the pervasive influence of electric motors in our lives cannot be overstated. So, what have we learned about electric motors today? Electric motors are indispensable in our modern world, converting electrical energy into mechanical energy. From their humble beginnings as simple electrostatic devices in the mid-18th century, they've evolved into a variety of types, including brushed and brushless, single-phase, two-phase, and three-phase motors. We've traced their journey from the birth of the first electric motors, pioneered by inventors like Andrew Gordon and Benjamin Franklin, through the significant evolution they have undergone. Today, These motors are integral to a myriad of applications, from industrial fans and power tools to household appliances and electric watches. The versatility of electric motors is awe-inspiring, as they can operate on either direct current or alternating current sources. Moreover, these motors are not restricted to rotation. They can also provide linear motion, making them a type of actuator. Next time you switch on a device, remember the fascinating journey of the electric motor that powers it.